So let's see more in detail what's happened when we load in a tank of LPG cargo. So just pass it on this drawing without considering the pipeline of the tank, but just the closed system tank. What we can say is that in tank A and tank B, the molecules, regardless of the two compounds, so propane and ethane, start to float because exposed to a certain temperature, surrounding the liquid surface, bouncing around the tank, and started to exercise a particular amount of pressure. So, for example, in this section, circled in red, the vapor sitting and surrounding the tank is responsible for creating the saturated vapor pressure inside the tank. But let me tell you, before going over, more about the saturated vapor pressure into the tank shape, because then it will be important to understand other gas transportation detail. So, vapor pressure is the pressure excited by the vapor floating off the liquid phase in a closed system. The vapor pressure will be saturated when there will be an equilibrium exchange between the propane molecules leaving the liquid phase and the propane molecules returning into the liquid phase. Now, because our closed system, that is our tank, is constant in its volume, we will have the situation where if for some reason the liquid in the tank is exposed during the time to an increase of temperature, what we'll have is an increase of energy that will break the intermolecular force, resulting in the increase of the rate of the molecules escaping from the liquid phase so rapidly that even the pressure exciting by the vapor within the tank will increase. And this is why in the enclosed system the temperature is directly proportionate to the pressure. However, if we continue to heat the liquid, it will go over until reaching a temperature called critical. Critical because at that temperature the molecules are not more able to come back to the liquid phase, and inside the tank there will be an increase in gas pressure that could expose the tank to a wanted failure. But let's come back to the point of that video for now. So I was saying just pass it on that picture. What I see is that in tank A loaded with liquid of propane has less vapor pressure than tank B loaded with ethane, simply because it has fewer molecules in the vapor phase sitting above its liquid, because the vapor of propane, as I said, it's harder to escape from the liquid due to its stronger intermolecular force, while for the ethane in tank B there is a higher vapor pressure, because for the vapor of ethane it's easy to escape the liquid phase due to its weaker intermolecular force. So the intermolecular force or force of attraction of liquid gas, its vapor pressure and its boiling temperature are variable interrelated between them, and those variables are interrelated also between the three different types of gas tanker ships. Ship type for which I have collected their structural characteristic in that table, and according to them and according to the propane and ethane chemical property, I can say that we can load and transport the two hydrocarbons in which type of LPG tanker and why? Well, try by yourself to answer now at that question. And to help, I leave also a picture showing the relation between the temperature and the vapor pressure of the propane and the ethane, with a more suggestion given by the area colored with different colors related to the various types of vessels. So this is my, let me take the last. So this is my suggestion, where the propane is shown by this curve, this one, and the ethane by this curve. Let me know in the comment if you want, or just take it as my contribution with the hope to have comply with the intention to be an easy explanation. So stop the video, look at the last two pictures and let me know. Thanks for watching.